Game 470, graphics and rendering. This is the final project. So let's walk through the scene first. There's four lights in the scene. There's one directional light. The sun and the moon are producing a directional light. There's one point light right below the flying saucer is a red point light, and there's two spotlights. Those two flying probes have a spotlight, and the colors are changing in the spotlights. And yeah, it's red, and then when it moves, or when it stays still, it's white, and when it moves, it's red. The sun is the light's rotating with the sun, and when the sun rises, the directional light color gets bright, and when it sets, it gets dark. And when the moon rises, same thing, but the moon's light is only a quarter as bright as the sun. So here comes the sun; it's setting. The sky dome. Notice it gets red around the horizon when the sun sets, and then the moon comes up, and you can see the reflection light of or specular light of the moon, and it's only a quarter as bright when the moon's at the peak. So those are the lights. The models, I have a flying saucer, this house, those flying probes, and the sky dome, and those are my four models. I'm using lots of textures. Let's see. I'm using a lot of pre-made models. So there's the crate and the spheres and triangles and the that block that has the faces textures mapped to the faces. As far as moving objects, those probes are moving in a square pattern. Basically, they move the X position for a little bit, pause, move the Y position for a minute, for a little bit, pause, and then they just make a square. Let's see, the saucer is slowly moving up and down in a sine wave, as you can tell. And the house has a light right there, and the light every, I think, 5 or 10 seconds it switches, so it looks like someone inside the house is turning on the light. So that's that. I have opaque objects and a few transparent objects. That ray right there from the saucer, that's just a cone, and the cone has a texture on it. And at the tip of the cone, the texture is 100% opaque, and as it goes down, it becomes more and more transparent. So it looks really cool. It's a really neat lighting effect. There's a pond, and the pond is transparent. It's a little hard to see because it's dark, but it's transparent. And then the house, the glass around the windows is transparent. So I have three transparent objects. Um, let's see what else. Yeah, that's about the scene. So the night day system I have going on, that's a sky dome. That's not a skybox. And the sky dome is following the camera, and the sun and moon are rotating around it. And I have another scene set up with the skybox where it's like the Truman Show, where it just surrounds the scene. I can configure this scene to have that. I'll do that really fast. So in the very top, this skybox here, if I set it to true, I'll set it to true, save, rebuild, and then you'll see it with the skybox to know that I have that working too. And that's a pre-made model as well. So I'm using some assets from that I made in Blender and some that I made. Yeah, so there's a skybox, and it's if you go to the edge, you'll see that it encompasses everything, and it looks worse and worse the closer you get to it. But that's clearly working, and it doesn't go well with this scene at all. So, but there it is. So the artwork, the textures I took from the internet or I made myself and I modified them using a program called GIMP. And the artwork I made myself in Blender. And I'm not very good at making artwork, so it doesn't look very good. But, this isn't an art class, so it doesn't really matter. But you can clearly see the Phong shaders working. The fog is working. As you can tell, when I go away, the fog gets... the further and further I get away, the more and more of the fog you see. And obviously the plain color lights don't have any fog. So I'm using 5 different shaders for this class, or for the scene. A flat color, a flat texture, a lighted color, a lighted texture. All of the lighted shader objects are looking at all four lights: the two spotlights, the one point light, and the one directional light. Um, and then I have another special shader for the sky dome, the when the dome was changing colors and everything when the sun and moon was rotating. So I'm using 5 different shaders to make this. So that's the scene. Let me walk through the code. So this is all the DirectX 11 setup, and this is pretty standard. You know, the depth test enabling the swap chain and everything like that. That's what this stuff is. So my init demos here, I made my own height map and I loaded in this texture parameters file here. Well, yeah, this is just for the height map right here. Here are my lights, and I can choose a position, color, and direction. And if it has attenuation, I can set the attenuation here. So the lights change colors, you can tell, and they move and they rotate and all that stuff. So that's all working. Here's where I load my shaders, and I have 1, 2, 3, 4, 5 different shaders being loaded. And that's, yeah, and I pass a little enum to tell me what kind of shader it is. And why don't I step into this a little? So this shader's class is a manager, and it holds the specific shader objects basically. And there's a base shader, um, flat shader, light shader, and sky dome shader. And when I add the shader here, it does all the work. It compiles everything. So I can build the shader data here, and it's all encapsulated very well. And there are no memory leaks, and it works great. And that's really that. So there's my shader manager. Now I have a texture manager, and I load all my textures here. So yeah, here are all my textures in the scene. Let me step through this. And here's my texture manager. I can load two types of textures, DDSs or TGAs. Almost all the textures are compressed DDSs. The opaque objects are DXT1, and the transparent textures are DXT5. And it really saves up a lot of memory because it's like I think 6:1 compression ratio, and they can hold bitmap, so they're pretty neat. And yeah, this is it. It's pretty simple. Textures are really easy. Not a whole lot there. And yeah, it's probably the simplest manager I have. Oh, and I have this null texture object too. So I used that when I was um, doing my graphics objects. I used the null object, and I'll get to that in a little bit. So that's that, and this loads. Oh, and I can set the wrap and the sampler. So or yeah, the wrap or the sampler. So I can do that here too. So if I want to if I want it to be mirrored or clamping or whatever, I can do that here. Next, I have materials, and materials are actually simpler than textures. And oh, all these can be shared. Shaders can be shared, textures can be shared, and materials can be shared, and I do share them all over. So and models can be shared too. So materials are even simpler than textures. Let me step into this manager. Oh, yeah, this is it. So basically, the material holds the ambient, diffuse, specular, and shininess parameters, and they can all be changed. And I do change them. The flashy lights on the saucer, I'm changing the diffuse light, and the obviously with the sky dome, I'm changing a lot of the lights. So that's that. And models. So models are there's a lot going on here. So I'm loading all my models here. Some of them are pre-made, like these are all pre-made, and my train is pre-made. The skybox is pre-made, and everything else I'm pulling from or the models I made in Blender. So let's step into this manager. So this one's a lot. There's a lot more going on here. I pass it a type, and it loads based on that type, or I can just load the wavefront data. I made a wavefront parser, and it's really big and ugly. So this huge file or function basically parses out the wavefront file. And first I do all the counts. I count all the vertexes, normals, UVs, and points and triangles. And on the second pass, I then uh, create arrays based on those counts, basically. So right there and the points. The second pass, I actually extract all the data into those arrays, and then I build the mesh. And the third part is I optimize the mesh. You don't need to have so many points, and that's what this does here. And I free up all the memory. There's no memory leaks in this, so I did everything works there. So that's that. Back to the models. Yeah. To add um, a wavefront model, I call the add function with the path to the obj file, and it does it for me. And to get a pre-made model, I call the bind function, and this binds the model that I call, or first it loads it, then it binds it. And so these functions basically create the pre-made models. I can have a plane. The plane is the pond. A cube, the crate, or the no, the crate's a different has different UVs. The cube is the sided cube that was rotating around the saucer. The crate, the pyramid, the sphere, the normal the skybox, and the train. And let's step into some of these. So this is just tedious. These are all you're just mapping out all the points basically, and all the winding of the triangles. And that's what all this does. The train was pretty big, especially calculating the normals. But yeah, it works. You can clearly see the specular light on the train, so that clearly works. And that's really all. That's the models right there. So graphics objects. So for every instance, it needs its own graphics object. So there's a lot of these. So there's one for the train, the sun, the moon, the sky dome, the house, the saucer, the probes, and the yeah, everything there. Let's step in, and there's a manager for it, the object manager. I'll step into this. Yeah, so when I add it, I pass it a type to tell me what kind of oh wait. So the graphics objects, when I render everything, I wanted to render as optimally as I could. So what I did was you pass it a enum, and that enum would tell you what shader to activate, or to render this graphics object in. So on startup, it after I've loaded all the shaders, it then saves pointers to the shaders, and when I draw this, where is draw? Here we go. Yeah, here. This is my draw function basically. So I will. Here's the sky dome. I To do the sky dome right, I had to disable the depth test, render the sky dome, the sun and the moon, and then disable or then enable the depth test. And then I have these draw flat instances or draw lighted instances, and these are basically. So for the flat instances, it's really easy. I activate the shader, and then I render all the instances associated with that shader. I am not activating the shader in the instance. I'm only passing in a material if it needs it, and passing it and activating the texture and activating the model. With the draw lighted instances, I am activating the shader. I'm only passing it the environment data once. I'm not passing the environment data every instance. That would be a waste. So, like if you can see some of these draw functions, like here's my light graphics, one of the lighted graphics objects. So this shader has already been activated, and the environment data has already been sent. I then activate the texture, which this is pretty simple. and that just sets, activates the texture right there. I then get the instance buffer and I set the instance data. And in this case, it's just the model view projection and the world instance. No matricy calculations are happening in the graphics object. It's all the I have a game object manager that does all the matrix multiplications and everything. And this function just draws. That's all it does. So like if this were to ever become a multi-threaded program, the one thread would just draw everything. The other thread would do all the math, do all the calculations, matricy calculations. So I activate the texture, I activate the instance constant buffer, I send it through, I activate the material, and then I activate the model. And this is the final step that draws the model, and that's all it does. And in the case of the flat texture, it's very similar, except there is no material to be activated. And the instance, the colors pass through the instance. So that's the only difference between the two. It's pretty simple. So back to the graphics object. Yeah, so it's kind of messy down here. I have pointers to all 5 of my shaders I'm using, and I have uh, lists of all the objects I'm iterating over. So each one of these has its own shader basically, or it's transparent. So to do transparent objects, I had to do something a little differently. Back to that draw loop. So first I would render all of my opaque objects. Then I would enable blending and draw all of my transparent objects or translucent objects and then disable blending. So that's how I did that. And the environment data, once a frame got built, I just rebuilt it. I took all the light colors, light positions, in case the game manager changed something. So that's this. And yeah, first build the environment data, then you draw the objects. Yeah. And that's pretty much that. So back here, so there's all my graphics objects, and like you need one graphics object per instance in the scene. But they can share materials, textures, models, and shaders. And the game object. So each graphics object needs a game object, and just like the graphics object, I pass it a enum. I made my game object a PCS tree, so it's not a strict linked list like the other managers are, and that makes it really easy. So if like there's a parent-child and the parent rotates or moves or something, all the children move with it. It makes it real easy. So let's step through this. Okay, so based on this enum, I determine what type of game object to make. The game objects do all the rotating and translation and stuff like that. So, like the color change game object, for example. Oh, and so there's a base game object, and it just holds. Yeah, and so I made all my game objects have an MVP, a world, a local, and a world inverse. Even though the flat objects didn't need the world inverse, I still had it. So, and then each game object has an update and an option of attaching light and an option to set the materials or to set the matrices. But these are optional. You don't have to use them. So in the case of, let's say, update. Oh, this is the lights on the saucer that were changing colors. It's just a simple state machine. Every these parameters are set in that init demo function, and the change rate and um, the colors, and they just change colors, and then once it's done, it repeats. And also, when I update, I calculate the world based on the parent and the local. I get the world inverse. I calculate the MVP, and I send these parameters to the graphics object. And then the child gets updated. The child gets updated, and then if there's a next, it gets updated as well. And that's how you do the PCS tree. And that's really it. And these are all just specific. If you know, for each like the sine wave of the saucer has a unique game object, and the sky dome has a unique game object, and the anything that has a unique type of motion has its own skybox or game object. So that's that, and all this gets put together, and it just works. So let's look at the shaders. So here's my flat color shader, real simple, not a whole lot going on. Um, it just takes the MVP and multiplies it and passes the color along, and then that color is what you see on the surface. So like the lights had this, use this shader, and anything that just had a plain color, use this. Flat texture, very, very similar to the flat color, except it's using a texture and it's ignoring the color. I reuse the same constant buffer. Yeah, so that's that. The light ones are way more complicated. The light color, so here are the four lights: the one directional light, the one point light, and the two spotlights. And yeah, it calculates all them. And here are my constant buffers: the instance data, the material data, ambient, diffuse, specular, and shininess, and the environment data, and this thing's huge. So there's that. The Fong model that I have, the directional light, point light, spotlight functions, and they all have attenuation and everything like that, and it all works. And that's that, and they're just all summed up and calculated, and the final color is set. And then for transparency, I use the W in the diffuse color to be the transparent number. It doesn't affect opaque objects, just transparent objects. As far as like optimizations, I could have done a lot more here. Like this model inverse and the eye position. This should not really be here. It should be done on the CPU side, but I guess it didn't. I don't know. And I could have passed this on the instance, but I didn't do that, so it's here instead. And then a lot of the light position and the model inverse calculations could have been done on the CPU side as well, but I didn't do that. And it would have made the instance buffer bigger. Plus, I don't think it was optimized pretty well. Like I'm not doing the MVP here. I'm just doing the some of the light calculations I'm doing on the vertex shader and the fragment shader. And then the light texture is almost identical to the color texture, except I'm doing the texture sampler and multiplying that by the ambient and diffuse light, but I'm only adding the specular light. And then, oh yeah, and I have fog on the um, pixel shader. All the fog parameters are coming in through that giant environment data. So the fog color, fog start, and fog range, and yeah, and it works. So, and then my final shader is a sky dome, and this one I custom made, and it just has attenuation. Like when the moon was rotating, you could see that the dome where the moon was brighter, and then the sky when the moon was further away, it was darker. So that's that. What else? Lights. I didn't cover lights. So I have my three lights here: my point light, directional light, and spotlight. And all the parameters are saved here. Like there's a direction, a position, and an attenuation, and they're all saved in a manager. And everything's a linked list except for the game manager. That's a PCS tree, but everything else is derived off of this double link class I made, and it can instantiate or destroy, and it's just a linked list. That's all this is. And my PCS link is here, and I have a PCS tree as well. And here's my PCS tree basically. and you can insert and remove, and it's real simple. There's not a whole lot, nothing too complicated. And the camera, I didn't mess with this much. I just made it so you can go up and down. That's all I did. It was already here, so I didn't really mess with it too much. So now up and down, I believe, is R to go up and F to go down. And that should be it. That is the course. Going down the checklist, skybox terrain, various models. I think that's it. I think that's everything. All right, that's the course.